Let's try our trio of solving methods on this linear system. Negative 4x plus y equals negative 5. 12x minus 3y equals 15. I think I'm going to have a pretty good situation as far as the slope and the y-intercept go, so I'm going to solve for y for these. First one's pretty easy. We just add 4x to both sides. Y equals 4x minus 5. And then in the second one, subtract 12x, and we can divide by negative 3. Y equals 4x minus 5. Interesting. So here we have two different looking equations, but when I put them into slope-intercept form, they're the same. Okay, so graphing it, B is where I begin at negative 5, and my slope is how I move. And this graph is for both of those equations at the same time, which means we have infinitely many solutions because they graph the same line. One line is directly on top of another. We have infinitely many solutions. Infinitely many points on a line, so we have infinitely many solutions. But that does not mean that all ordered pairs are solutions to this system. Only the ordered pairs on the line. What that means is we can assign a rule that will allow anyone to generate these ordered pairs. So let's let x just be x, and notice that up here y equals 4x minus 5. So instead of y, we're going to drop that expression for y in the parentheses. 4x minus 5. This tells anyone that if I want the ordered pairs that solve this solution, then I can just take any value for x, and I plug it in for y. 4 minus 5 will give me negative 1. I can plug in 2. 8 minus 5 will give me 3. I could plug in negative 1, and I'll get negative 9. And we can see these points directly on the graph. 1, negative 1 right here. 2, 3, negative 1, negative 9. So this expression for an ordered pair helps us to generate all of the ordered pairs that fall on that line that are solutions to the system. Some textbooks, some instructors, some situations, instead of using x, they will pick a different letter. So instead of calling it x, they'll say let t be any real number and replace the x with the t. And they get a different expression, but notice it's just a variable change. Instead of x and 4x minus 5, they have ordered pairs that are t for t minus 5. Usually this is done because x stands for something, x means something, and t is considered a parameter, a different variable that can represent relationships in a slightly different way. For me, in our class, it doesn't matter to me which variable you use. I want you to be aware that this situation of changing variables exists. A lot of times s and t are used for parameters, and so you may see that in other textbooks and in other classes. Let's see what would happen if we try to solve this by substitution. Negative 4x plus y equals negative 5. 12x y equals 15. I'm going to take this first one and solve for y because I see that I have y with a coefficient of 1. Y equals 4x minus 5. And then I'm going to take that expression, 12x minus 3y equals 15, and plug that expression, 4x minus 5, in for y in the other equation. Remember, starting out, we only use the first equation, then we have to shift to the other equation. We have to use both equations to solve for one variable. Multiplying out, 12x minus 12x plus 15 equals 15. When I try to solve this, look what happens to the x's. The x's cancel each other out. The x terms combine to 0. And I'm left with 15 equals 15. Now, since 15 actually does equal 15, that means we have infinitely many solutions. And we can generate those infinitely many solutions based on what we solved for above, x and 4x minus 5. The big situation to notice here is that I have infinitely many solutions. So when I try to use substitution, one of my variables disappears. And I'm left with just numbers, no variables. So I can't solve for any variables, but those numbers are in a true statement. since they are true, we have solutions. Contrast this with the problem before, where we had a false statement and there were no solutions. So a false statement leads to no solutions on the system. A true statement will lead to infinitely many. Solving by elimination. If we eliminate the y's, we would multiply this first equation by 3. So 3 times -4, -12x plus 3y equals -15. And then I'm going to copy the next equation over. 12x minus 3y equals 15. And you might be able to see what's going on here. I have the same terms. They're just opposite in sign. So when I add them together, 0x, 0y, 0, I end up with 0 equals 0. Another true statement. So I have infinitely many solutions. This case, it's a little bit different as far as finding out what form those solutions will take. Because I didn't do any substitution, I don't have a variable solved for. So if I didn't already have this information from doing substitution or graphing above, I would have to do a little bit more legwork and take that first equation and solve for y. But since we already know what it is, we're just going to write it down and have that same system.